Okay, let's start off with a little bit of review of matrices again. I've got two matrices here. This one would be a 3 by 3 because it has 1, 2, 3 rows and 1, 2, 3 columns. This here is a 3 by 2 because I have 1, 2, 3 rows and 2 columns. So if I want the second row, here, write down the second row of the numbers in the first matrix. Here's my first matrix. That'd be 1, 3, and 8. If I want to write the first column in the second matrix, I'm talking about 10, 0, and 6. Okay, what we're actually going to be working on here is multiplication of matrices. Now this is different from our multiplying by a scalar multiple. This is taking two matrices. The notation I use here would be matrix A and matrix B, and putting them together as matrix AB. I can multiply two matrices if the inner dimensions here are the same. Okay, so for example, if A is a 2 by 3 and B is a 3 by 2, since these dimensions right here are equal, I can go ahead and multiply them. And in fact, the product of AB, the two outer numbers, this 2 and that 2, will tell me the dimensions of my leftover or resulting matrix. So here we go, another example. Let's say that A is a 3 by 1 and B is a 1 by 2. Because the inner sides there are equal, I can multiply them together to get AB. And my AB will look like a 3 by 2. Okay, an example of ones that wouldn't work, but let's say A is a 3 by 4 and B is an additional 3 by 4. Because 3 and 4 are different, they're not the same, I would not be able to multiply those matrices. Alright, so let's go ahead and just kind of decide whether or not we can multiply them. Okay, this is a 2 by 1. This is a 2 by 2. Those numbers are the same, so I can't multiply. Here I've got a 1 by 2 and a 2 by 2. Those are the same, and the answer, or my resulting matrix, would be a 1 by 2 matrix. Here we go. I've got 5 and 5, those are equal, and my resulting answer would be 2 by 1. Okay, 4 by 1 and a 4 by 1, so there we go. They're not the same again, so I can't multiply. Alright, so hopefully that makes sense. I would definitely check that out before you bother going through all the matrix operations or all the possibilities. But here I'll show you how you can actually multiply and get the resulting numbers for the matrix, but double check. A is a 2 by 2, B is also a 2 by 2, so that means I can multiply them together and AB will end up being 2 by 2, which leads me to my process. So I'll start off with a 2 by 2, and I'm going to put blanks 4 spots right there because I'm going to end up having 4 entries. 2 rows and 2 columns. Now I go by position. This first position here is row 1, column 1. So I'm going to grab the first row from matrix A and the first column in matrix B, and I'm going to multiply their corresponding spots. So like the first number I see in the first row is 4. I'll multiply that by the first number I see in the first column. Okay, I'll do the same thing with the second number in the first row times the second number in the first column. And I'm going to take those products and I'm going to add those together. So negative 4 to positive 4 gives me negative 16 plus 1. So my first entry here will be negative 15. Yeah, I'm going to move over to row 1, column 2. So now it's still going to be this row 1 of 4 and 1, but now I'm going to slide over to column 2. So now it's 4 times negative 3 and 1 times 2, and I'm going to add those up. And it's always multiplication adding, so here's negative 12 plus 2, that's negative 10. Now, I've got all my row 1 numbers in my answer, so I'm going to cross out row 1. I'm done with that. And I'm going to move on to row 2. Okay, so again, I'll go by position. This is row 2, column 1. So I'll take row 2 and column 1. And I'll go 0 times -4 plus -2 times 2. That's going to give me 0. That's going to give me -4. So there's my resulting number. I'm done with all my row 1 numbers. So I'm left with row 2, column 2. So row 2 again, and this time column 2. So 0 times -3, and -2 times 2, and that's going to give me -4 as well. And there we have it. The resulting matrix of right here would be A, B, and that's my 2x2. Okay, same matrices basically. I'm just switching the order. So now what that means is I'm still going to get a 2x2. But to get my answer here in row 1, column 1, I'll take row 1, column 1 like this. So -4 times +4 plus -3 times 0. And this is going to be -16. That's going to be 0. So my first number here is -16. Then row 1, column 2. So I'll stick with row 1 from matrix B. And the reason why I'm picking B first is because it's B and then A. Okay. And it's going to be -4 times 1 plus -3 times -2. Okay, so -4 plus 6. That's going to leave me with 2. Okay. Done with that. I'm going to move on to row 2, column 1. So 1 times 4, 2 times 0, and that's going to leave me with 4. Okay. And then row 2, column 2. So I'm done with that one. So 1 times 1 plus -2 times 2. So 1 minus 4, so -3. Okay, so now that's BA. And the reason why I'm doing this is I want to show you that this BA and what we just got done doing earlier with AB, they're both possibilities. Like I can multiply out the two matrices, but I don't get the same products. So I don't know if you remember commutative. That means, you know, something like is 5 times 2 10? Sure is. Is 2 times 5 10? And it sure is. So with multiplication, I've got commutative property, but with matrix multiplication, no. The answer to AB is not the same as the answer to BA. Okay, so I will show you how to do this with your graphing calculators. Okay, make sure you grab a TI-84. I've only got so many in class, but hopefully we get enough to scrounge that up. I'll show you how to enter this, but I'll also show you how to do it by hand. I'll kind of tell you about the deal as well. But let's say for AB, that means I'm going to take, well here, better check my dimensions, the 2 by 3, 3 by 2, so my answer is going to be a 2 by 2. So 4 times 1 is 4. -2 times -3. Okay, 3 times 0. So 4 plus 6 plus 0, that is going to be 10. Okay, I'm going to move on to the next column here. So I'm going to go 4 times 5 plus -2 times 2 plus 3 times -4. So 20 minus 4 minus 12. That's going to give me 16 minus 12, 4. Done with that column. Okay, so 0 times 1 is 0. 1 times -3 is -3. Negative 1 times 0 is 0, so there's negative 3. Okay, done with that row. 0 times 5 is 0. 1 times 2 is 2. Negative 1 times negative 4 is 4. So I've got, here, I'm going to write that down real quick. So I'm sorry, I'm going a little bit quick here. So there's my three products when I multiply row 2, column 2. So 0, there's 2, and there's 4, so 6. Now, what I'm going to do is I'm going to let you use your graphing calculators, but I'm going to require you to show your work for row 2, column 2. So the answer that I got in row 2, column 2 was 6. I need to see all that, okay? Because that's the work for taking row 2 times column 2. You show me that work, you get all the points. If you don't show me that work, you just show me your answer, you get none of the points, because I want to make sure you understand how to do matrix multiplication by hand. Okay, so BA, again, you can do this in your calculator, but BA means that you would do this, that B would come first. So there's my matrix B. And matrix A would come second, so there's my matrix A. So just check, you know, here I got 3 by 2, I got a 2 by 3. It's possible those are the same, but this time my answer would be a 3 by 3. Okay, so changing the order of the multiplication can really change the answer when it comes to matrix multiplication. I'll let you type that in your calculator. I'll show you how to do that in class. So there you go. Same thing. Let's try C and D. So C is going to come first. There's my 2 by 2. Okay, here's my D. Here's my 3 by 2. So there, before I even start, because 2 and 3 are different, I can't multiply. So that's going to save me any time because I'm pretty much done with the problem. Okay, and now if you were ever to run into this, we talked about equivalent equations here when we were doing addition, subtraction, whatnot. But equivalent means that these two matrices multiply together to give me this last one, which is a 2 by 2. Here's a 2 by 3, a 3 by 2. Yep, I should end up with a 2 by 2. So let's say I want to find, say, y. The way I look at it is this is row 1, column 1. So I'm going to take row 1, column 1, and I'm going to work that out. And I'm doing row 1, column 1 because y is in the row 1, column 1 spot. So there's 36 plus 2 minus 3, 38 minus 3. We get 35. So right there is 35. Okay. If I want to find x, a number of different ways, but I think of it this way. This is in row 2, and this is row 1, or sorry, column 1. So what I'll do is I'll take the answer that was in row 2, column 1. So that's negative 13. So I'm going to do the same work, negative 2 times 9. I'll put that x where I normally would put the number, x times 2. And then 1 times negative 1. And that's going to be equal to negative 13 again, because I'm taking row 2, column 1. I need the answer in row 2, column 1. So negative 18 plus 2x minus 1. Combine like terms, so 2x minus 19 equals negative 13. So 2x is equal to 6. X is equal to 3. So there you go. That's how you solve an equation when it comes to multiplication.